Let's continue on with lesson 3.5. We're going to use Desmos more now to answer some questions. So instead of finding the line of best fit or the linear equation that goes through these data points, we are going to use Desmos to find the least squares regression equation like we did on the previous problem. This one here is for your discussion. And so I'm not going to do it, but I just want to remind you that to get this data in, you can type that in by hand. If you open a Desmos graphing calculator, insert the table, and then you enter in the data. So that's one way to do it. And so the table would be there. Look at these numbers, and then you would go ahead and put in the data. You'll start typing them in. And so another way to do it is right here. There is a website. It's long to type in, but it's faster to type that in than to try to insert this table of values. And so that'll end up looking like that. Notice the table's already done for you, and you can see what the graph looks like. And then you can hand approximate what the graph would be there, because then you're going to go ahead and answer these questions to do that. But again, if you type that in, you'll get this data here. If you're going to do it by hand, you just start entering the data in after you insert the table, and then you start typing in the values there, the points as they come in. And so you can see that would be 246 is the next one. And so the data would come in. You got to, of course, zoom around and look for the data. If you're going to do it by hand, what was it, 1900, 2000. There's our first point there. So you would be able to take care of that by hand, but you have the data already inserted for you. And so you'll do that for your discussion board here. Let's continue on and do the next problem together, so that you can use this to guide on your other work. So this data is also available, ready to go, or you can enter it in by hand. But let's go ahead and take care of that first. Okay, so again, I type this website in instead of hand entering that in, and then you get the data that looks like this here. You get two data sets. The data is in already, so you can see both data sets using that website there. And now we can go ahead and answer some of these questions. I want to also show you that sometimes when you enter the data in, or it comes in, you mess up the graph and it looks like this, and you say, I don't see any data. And so that's where the zoom in and zoom out would work. And if that doesn't work also, if that somehow gets you messed up, you can't find it, the wrench would work. And then you could type in your values like on the bottom here to match up. So you can see my X value, X-axis, my X values go from 2005, from 1991 to 2005. So in a case like that, I can put 1991 here, there you go, up to 2005. So you can see it starts to come in, and then I can put in the y-axis. You can put in, it looks like the values go from like 18,000 all the way up to 18,000 is the smallest, all the way to 41,000. So you can go ahead and start to put some numbers in. Let me go 18,000 all the way to, what do we say, about 42,000. And so you can see you get the numbers there, and then you can zoom in and out better so you can see the data there. So that's the way to do it. Let's go ahead and answer some of these questions here. So we created the scatter plot already. What do you predict the correlation coefficient to be? Here, so we're looking at this data here from the graph, and I kind of seen, I know they're going to be positive, so I'm going to have kind of like a line going through them. This one looks pretty straight, and so again, when we say what's the correlation coefficient, we're looking at these numbers here. Which ones do they look like? And so it's just a guess. Right now you guys are learning how to do this, so I mean it's pretty straight, so I might say it's in the 0.9s somewhere because of of how good the data looks. It's almost like a line here, but it's for sure going to be positive in the sense that it's going with the data in some way in this increasing fashion there. So I'm looking at between 0.8 and to 0.80, 0.95 as the correlation coefficient. I'm just guessing now because in reality we're actually going to go ahead and calculate what those technology. We're going to use Desmos, the correlation coefficient for min. What does it tell you about the relationship? And then we go ahead and we'll do the women. So let's go ahead and take a look at this real quick. Remind you how to do that. So looking at this data here, let's make sure we can see min income, median income for men over these years is the one that's more, unfortunately. And so from here, the men will be the green one. And then from there, we would go ahead and type in, remember there's a command that we would use to do this, which is right here in our notes. This is what we're looking for. And we're using this here, regression using technology there. So we're going to go ahead and it's Y, again, Y1. So use the board. Here I want to use the sub 1, arrow over. That symbol, that's the special symbol to say, to tell Desmos to find the least squares regression, X1, and that's matching up here, notice, with these equations there. And then you're asking to find the least squares, you're doing the mx plus b. And so then from here, we get the R value of 0.79. That becomes the actual R value here, 0.79. So I was close with my guess. So here the actual one from Desmos, right? You get R equals 0.79 from Desmos. And so what that says is that it does have a positive relationship. As the years increase, men's income is also increasing as we look at that positive value. We can do the same thing for women. That we have all this data into Desmos and we found the least squares regression lines. You can see these equations here. We have the information we need. We can go ahead and answer the questions here. Like I said, we were close with the women, with the coefficient for men, 0.79. When you look at the women's, it turns out to be 0.96. That again comes from the R value right here. I'm abbreviating, so there's your R value right there. What do we know about the relationship? Well, there's the graph that we have from Desmos. You can see that they're increasing. These are the equations, the one in green and purple. Those come again from right here. Your M is your slope and your B is your y-intercept. And so once you take those values from Desmos, who's calculated the least squares regression line, you have these equations here, and then we can use those to make these predictions here. You can see how I substitute those values in and then just get the values. You can see I did it in Desmos here. You can also do it in your calculator. And then notice here as you have these equations here, you have the slopes. What do they mean? You can see these numbers. It's increasing in income per year by those numbers for men and women. Women line steeper, which means their income is increasing more. So that's how you would use it. I'm not going to worry about these last two here with the enter more data in, but that's how you would use Desmos least squares regression equations to make predictions. And then you could use this technique here to do your discussion for these problems here.